All right, welcome back. We are going to be looking at Hexagon first. Our chunk, we're going to work with a single chunk first, and that way we can concentrate on getting our basic mechanics out of the way, such as placing new nuggets on the scene, placing new hexagons on the scene, deleting them, changing the material, connecting them, etc. It's going to work a lot like a hexagonal Minecraft. So the first thing I need you to do is go to the Assets folder to the Scenes folder, right click in the Scenes folder, and add a new scene. Call it, if I can find scene, call it Hexagon. Open it up, delete the camera from the scene, go to prefabs, drag the character up into the scene. I'm going to put it up a little bit higher. On the directional light, make its Y position some crazy number way out of our way. 1500. That'll work. Go to the Scripts folder, create a new folder and call it Hexagon. Open it up. Underneath there, create a new folder, and we're going to call that single lab, or H single lab 0. Under there, in that folder, create a new C# script, call it HS lab 0. So we really don't need to give it a long name. In the scene, right click in the hierarchy and create empty. Reset its transform. Call this single labs. Right click on it, create another empty. Call this HS lab 0. Drag with the HS lab 0 selected, drag the script HS lab 0 onto it and save the scene. Double click on HS lab 0. I had to go to the dark mode on Visual Studio. I don't know what the big deal about that is, but it was necessary. It's kind of messing with my recording, I guess you say. All right, we need to create some support structs in here. In our class, we're creating them in the class so that we don't have to come up with a new name for each lab. So we can just use the same names over and over again. And that way it won't mess with IntelliSense. First one is called Nugget. We will have material presets. So that will be our first value. And our second value, which will be shape. Right now, for the first lab, shape will have two possible values, 0 and 1. Either it is or it isn't. But later on, we'll have more shapes. Our next struct is a very simple create results, and this is simply going to give us access, quicker access reference to what we created. We could get it, do a get components, get all children, that kind of stuff, but I like to do it this way. Keep a reference local. It's not going to hurt our memory because it's just a reference. Next up, we need the actual material preset. This is a very simple class right now. It'll get a little bit more complicated later on. But in most cases, it will have 3 or 4 values in this array. The number will point to a material in a list of materials that we have, an array of materials we have. The side of the hexagon will tell it which value, which index to use. So for instance, all the sides on our hexagon normally will point to 0. The top will point to 1, the bottom will point to 2. The value in 0 in this array will tell us which material to use. It's actually a lot simpler than it sounds. Unless that sounded simple, then exactly. Face index group. We could use Unity's built-in combined mesh functionality, but that happens on the main thread, and we actually want a good 400 chunks in our scene easy. So we want to be able to see in all directions a pretty good distance. Because of that, we want to actually process our meshes ourselves. We want to combine all of our meshes, all of our sides, all of our hexagons into one mesh, into one model ourselves. And we want to do that off thread before we come back on thread to actually create the mesh. So for that, we have to have somewhere to store our face indexes. Now, in the beginning here, we will be using submeshes. Actually, we'll use submeshes all the way through, but we'll also use atlases later on. Right now, every material gets a face index group. So we want to actually count how many different or distinct values there are in face indexes. So there will be repeated values in there. Yeah. It just gives us a fast way to get to the count, other than doing a length on the face indexes. Also helps us debug easier. All right, so we need a evaluate results also. Evaluate results, when we evaluate a mesh, we need some place to store all the vertices until we're ready to create the mesh, until we get all of the vertices, all the UVs, and all the normals. Right now, we'll let Unity calculate our tangents for us, but later on we'll import those from Blender. And since on this first lab we have to hard code everything, we'll go ahead and just hard code our normals. And I will explain those in a moment when we get to it. Copy all of those and paste them. And put a temp in front of each. So our vertices, our normals, and our UVs will be, these arrays will be initialized to a vertice limit that we set momentarily. We will never resize these arrays. We will not null them out or empty them, because we are going to count as we're adding vertices to it, how many vertices we added, and from that count we will initialize these arrays and copy those values over. Because we're not calling new over and over again on these, we're calling system array resize, system array copy, we get no glitches. Okay, so there's a little bit more RAM usage, but overall we get no glitches, and that's the important part. The scene doesn't glitch on us, and our RAM usage actually does stay in a very nice area. So our vertice index, our vertice count is right there. Our total face index count is different and is actually related to this, and it's different per material. How many mats we're actually passing in when we initialize, how many materials we actually used. This will give us our total number of submeshes. This is the total number of possible submeshes. Tomatoes, tomatoes. And since we have a vertice limit that will be smaller than unities, well, I mean, even if we made it the exact same size as unities, we need to know where we're approaching that vertice limit so we can break. The only one of these we actually need is break in, but I like to record the column we broke on, the Y we broke on, and the row we broke on to debug. It's not necessary. These are not necessary for production, but they're definitely not going to hurt us. So we are setting up pooling right now. I can't really just totally explain pooling until we get to our labs common class, which will host all of this information in the next lab. But in this lab, we are already using some techniques that we'll use for pooling. Pooling is like putting everything in the swimming pool. All of our chunks will use a number of our chunks. Our chunks will share a common. Normally I put like 9 chunks to a common. And that keeps the RAM usage down because each chunk doesn't have a separate copy of these. And also, each chunk will be created even if it's not being used yet. It'll be ready to go later on. And we can change our chunks, columns, and rows to turn them into different chunks. But that's all later. The only temporary we really need to initialize here, and this is the only time we initialize them, is the temp. It is the face index groups because it has subarrays. The rest will initialize the first time with the system array resize. Which is less burdensome on the system than a new. So there are more face indexes than there will be vertices. Multiple face indexes will point to the same vertice. And of course, each face will have at least 3 indexes. Normally it'll have 6. In our first lab. Okay, that's our initialize. So each time a new chunk goes to use this struct, it needs to call reset. And the only new we're calling is on our face count there. And we are resetting all the other values. So if a chunk is broken into multiple meshes because it approaches the vertice limit, we don't want to reset our breaks. But it has to call reset for each pass, for each new level. So it will call reset breaks false. Alrighty. Those are our initial structs, our initial sport structs as they are right now. We have one sport class to write before we actually get into writing this chunk. And like I said, for the first lab, it'll just be one chunk by its lonely self, floating in space and time. You can feel sorry for it. But that will give us our setup. I will see you in the next lesson. All right, welcome back. And if you're getting something out of these tutorials, please hit that subscribe button. You may hear some stuff in the background, a little bit of wild weather going on here today in Southeast Texas, but that's pretty normal. Let's jump on up here. We are about to declare a whole bunch of fields in our class, and we're going to be that much closer to having our first chunk done. So we will have a nugget count. 16 nuggets by 16 nuggets. Why do you use 16? Because 16 times 16 is 256, and the maximum size of a byte is 255. And of course, if that's 0 base, then of course it's really strange though that if you go smaller than 200, if you go smaller than 16, your application will become a little bit more clunky because you have so many more objects in it. If you go greater than 16, although you can, the application becomes laggy and clunky. So either way it goes, 16 is still a great number to work with. I'm sorry, Microsoft, that your IntelliSense cannot keep up with my slow typing. Wants to keep on putting other numbers out or other words out there. So our level size is basically the size of a single level, not the overall height, but it's 16 times 16. Vertice limit, we've already talked about that a little bit. That is how many vertices we're going to allow in a mesh. We're going to set it kind of low. We actually won't force a new mesh in this lab, but we will in our next lab. And we're going to set it kind of low so we can see that working. We will have a simple state machine that is just an enum. Do want it spelled correctly. No, we don't need waiting right now. So I use ing. This is a primary state. This is a primary state. Whenever I go to the state, I set my overall state to the same name ing. That tells me when we get into multi-threading where I crashed. Sometimes with Unity, you'll have a bug, but Unity won't even report it if you use a multi-threading that's not from Unity. So that's where that comes from. So all of my main states here have an ing version. the state we really hate, error. After 30 years in this in IT, errors still bug me. So we need a reference to our character camera in our scene. We won't use it immediately, but we will be using it once we get into interaction. So we need to reference our common folder. We'll just say static. Reference it statically. I like to keep a copy of my height map around. We don't really use it, but it sometimes comes in good for debugging. And you can turn it into an image for mapping, etc. And if you don't use it, you can just get rid of it. So in Hexagon, our X-org and our Z-org must be floats. In voxel, they can be integers, but over here, they have to be floats. I don't know what I was typing there. And they're based on our nugget count times our column and our row times either 0.75 or 0.8660254, which you will become familiar with when working with hexagons. Wrong. So for debugging purposes, I put these at a member level so I can see them in the inspector. Let's go over to the inspector real fast. Thank you there for that, Microsoft. Actually, you guys can't hear my system audio, so you have no idea what I was saying there. But yeah, I like to be able to see values here. So to do that, instead of declaring these local to the handle up input, which we'll be writing shortly, I declare them at the member level, and that way I can see them. The same thing with the normals. It can help you debug. Wow, new word. It must have really been a new word since I almost typed it twice. All right, so we're going to set up our states here, or our structs, create result and evaluate results. We're going to seed them with some basic values, or the standard values. go ahead and write two of our functions right now. And then we'll go write our shape class, because we need that before we can actually run. And then we'll come back and write everything else. So we initialize, or we create our nuggets array to the max height, but we're going to generate, of course, to the generate height. Nugget count is, we'll look through our nugget count twice here, once for the Z and once for the X. I'm going to go ahead and wrap this in a try catch, because this is most likely where we'll get an error. Get our 2D index for our height map, because it is 2D. Loop all the way to the max height. Now get the 3D index. All right, let's go over this real fast. Getting our 3D index, of course. That's the nugget we're going to set up. We're just going to have the default material right now to set to 0. Our shape number, if our Y is less than our height being a float that is multiplied by our generate height. If our Y is less than that, then we will have a shape. If it is not, or if it is greater than or equal to that, then it will be 0. Simple enough, I think. Now we tell everybody that we've been generated. We're not created yet, but we've been generated. And then we set a state to go ahead and do the next state, pre-evaluate. Like I said, simple state machine. Alrighty. And for the rest of our functions, we need something called a base shape. Base shape, we're going to plug in right down here in the next tutorial, and it'll be encapsulated also. It'll be a scriptable object, and I hope to see you there.